Good afternoon, ladies and gentlemen. Dr. John Belkowitz here, Intelligent Concrete. We're going to be doing some basics engineering here. We're working with a cantilevered beam. And with our cantilevered beam, we have at our A, we have our fixed support that has a resistance both in the X, Y, and a resistance against the moment, similar to what you would see a flagpole in the ground. So we're going to go ahead and do the math to figure out the reactions and then do the shear diagram for you. So let's go ahead and get started. Just like we did with our simply supported beam, I'm going to go ahead and do a free body diagram. My sign convention, my Y, X, and my moment are all positive. Then I'm going to go ahead and draw out my cantilevered beam. Let's go ahead and make sure. Yep. Okay. So there's my 100 pounds. Oops, I do not need this off to the side. I have my X, my Y, and then my MA at 10 feet. Okay. So, just like before, I've got my free body diagram set up. Now what I need to do is solve for my forces at A. So sum of forces in the X direction equals 0. AX, we go across the beam. There's nothing there, so equals 0. Okay, and then we go sum of forces in the Y direction equals 0. So AY, positive. We go down the beam, minus 100 pounds equals 0. So therefore, AY equals 100 pounds. All right, so we're done with that one too. So go ahead, we're right here. We've got 100 pounds. So that pushes up from our reaction. Nothing happens during the extent of the beam until we get to our free end, where it pushes us back down to 0. Now let's go ahead and draw out the moment diagram since we're here. Okay, so we have a positive constant slope taking us back to 0. We know, oops, wrong marker. We know our free end equals 0. So to get that positive constant slope to get us to 0, we're going to need a negative slope. And our max moment, let's call this area 1. Our max moment equals the area under that curve, which is 100 pounds times 10 feet equals 1,000 foot-pounds. So here's our negative, 1,000. And we have that constant positive slope taking us back to 0. Okay, so there we go. Let us know if you got any questions, any mathematical concerns. Don't forget to like and subscribe. Ding that bell for notifications. Have a great weekend, folks. Go concrete, beat asphalt.